Good morning, everyone. I am Dr. HimaBindhu, Assistant Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering. And my today's topic is Euler's angle and homogeneous transformation matrix. What do we mean by Euler's angle, and what is the use of homogeneous transformation? What are its advantages and disadvantages? And what are the applications of these particular Euler's angle and homogeneous transformation? All that we will be studying in today's class. Coming on to the first concept, that is Euler's angle. What do we mean by Euler's angle? As we all know, in the previous session we have discussed about the rotational matrix, right? What was the use of rotational matrix? What was the use of the this particular rotational matrix? What was the application of rotational matrix? As we all know, right? The rotational matrix is generally used to analyze the orientation or position of a particular robot wrist, right? In order to identify the position, or we may also call it as orientation of a robot's wrist, we were using the rotational matrix, right? In the same way here, again, the Euler's angle and the homogeneous transformation is also used to identify the orientation or position of the particular robot's wrist in different applications, in different methodologies, right? There we were using a three-dimensional plane or two-dimensional plane rotational matrix, and the matrix was being determined where we were telling that the transformation matrix of a rotational matrix should be equal to its inverse, right? The inverse rotational should be equal to the transverse of the rotational matrix. That was being determined in the rotational matrix. And now what we will be seeing in the Euler's angle, what will be determined? The determination will be same, but the methodology of the axis rotation will be different, right? The determination will be same, but the methodology to determine that particular orientation or position will be different depending upon the rotation of the axis, right? So here in Euler's angle, we will be having three different angles. That is, we will be having theta, pi, and psi. Right? In the Euler's angle, we will be having three different angles. We will be having three different angles. That is theta, pi, and psi angles, where these particular three angles will be determined based upon the rotation of the axis, right? Based upon the rotation of the axis of the robot, these particular three angles will be determined. So initially here we have taken three angles, x, y, and z. Right? Here we have determined three different angles, three different axes, that is x, y, and z. For these axes, we will be finding theta, pi, and psi, where this axis will be rotating about its own axis, right? The axis here will be rotating about its own axis, right? We have x, y, and z axis, right? For example, this x, y, and z axis. Now, these particular axes will be rotating about its own axis. The rotation of the axis will be taking place about its own axis rather than depending upon any other axis, right? Rather than depending upon any other axis, these particular three axis rotation will be done according to its rotation, according to its angle. That is, these axes are independent axis where it is not dependent on any of the other axes. That is, x is not dependent on y, or y is not dependent on z, or z is not dependent on x. They are independent axes which rotate about its own position, which rotates about its own axis. So that is known as the Euler's angle. Right? So that particular methodology is known as the Euler's angle. That is a body which possesses the three rotational degrees of freedom, or the body which is independent of its quantities is known as, it's represented as a Euler angle. Right? It is any particular body which possesses 3 degrees of freedom and which is independent of itself represents a Euler angle. That is, it is a method which specifies the rotational matrix in terms of 3 independent quantities. Right? The Euler's angle is nothing but it is a method of the rotational matrix where three independent quantities are being determined, where that particular determination is known as the Euler's angle. Now we can see this figure here. Right? In this figure, we can see the x-axis, we can see the y-axis, and we can see the z-axis. Right? Here we can see the z-axis. Now each axis has been rotating about its own direction, about its own axis, where it determines the angles pi, theta and psi. Right? Where it is determining the angles pi, theta and psi. Generally, for any particular proper Euler angle determination, we will be taking these coordinate systems. Right? In order to properly determine the Euler's angle, we will be determining these particular quantities, that is zxz coordinates, or we use xyx coordinates, or we use yzy coordinates, or we use zyz coordinates, xzx coordinate, or yxy coordinate. Depending upon the proper Euler's angle determination, we will be using these particular types of quadrant systems. Clear? Do you understand? Now, in this particular figure here, the fixed coordinates are x0, y0 and z0. And in these coordinates, the fixed coordinates are x, y and z. So these are the fixed coordinates which are rotating about its own axis, and the angles have been determined as pi, theta and psi. Clear? And those angles are called as Euler's angle. For example, now let us take the axis A. Right? Let us take the axis A. Now this is the axis A which is having three coordinates A1, A2 and A3. Now when the axis A is moving to axis B, when the coordinate system A is moving to the coordinate system B, it is taking an angle psi. Right? It is taking an angle psi. Right? A to B, it is taking an angle psi. Now, when the axis is moving from B to C, when the axis is moving from B to D, it is making an angle pi. Right? That is this particular angle. When the coordinate system is moving from B to C, it is taking an angle of, when the coordinate system is moving from C to D, it is taking an angle theta. Right? When the coordinate system is moving from C to D, it is taking an angle theta. That is, there is the rotation of the matrix being taking place from A to D. Right? There is a rotation of the matrix taking from A to D, where from A to B it is taking an angle pi, from B to C it is taking a rotation of an angle pi, and from C to D it is taking a rotation of an angle theta. That is, overall, when any particular quadrant system is making a rotation from A to D, it will be taking these particular three angle rotations. Right? It will be taking these particular three angle rotation, that is pi, theta and psi. Right? That is, when the rotation of the axis is being taking place from A to D, first, as I've told you, it will be moving from A to B, then it will be moving from B to C, then it will be moving from C to D, as I've told you. That is A to D is equal to A to B, A to B, B to C, and C to D. Now, how do we write, what are the angles which have been taking place in this? From A to D, it is an angle of psi. From B to C, it is an angle of pi. And from C to D, it is an angle of theta. Right? Yes or no? Now, when the rotation of the axis is being taken place from A to D, it will move from A to B, then B to C, and then C to D. Now, what is the angle rotation being taking place from A to B? It is nothing but pi, psi. Now, from B to C, it is pi, and from C to D, it is at an angle of theta. Right? So, this particular axis in terms of x, y, and z direction. Right? In terms of x, y, and z directions. Yes or no? So, how do you write this equation? You write it in this particular form. Right? The rotation of the axis from A to D with respect to the axis x, y, z, and with respect to the angle pi, theta, and psi will be written in terms of rotation of x comma pi at from the axis A, rotation into rotation of y comma pi for the axis B, into rotation of z comma theta for the axis C, where generally we call it as the roller rotation of the robo, or the pitch rotation of the robo, or the yaw rotation of the robo. Clear? Generally, we call it as the rotation of the roller, or the rotation of the pitch, or the rotation of the yaw. Will be taking place in three different directions, x, y, z, or three different axes, A, B, and C. Right? So, this particular rotation will be taking place in a 3 by 3 matrix. Right? So, this particular rotation of the axis from A to D will be taking place in a 3 by 3 matrix, because it is a rotation of 3 axes. Right? So, any rotation can be described by 3 successive rotations. Any rotation of the matrix of any particular robo will be taking place by 3 successive matrices which are independent and which gives an 3 by 3 matrix axis. Now, for example, when you consider a ZYZ coordinate, right? When we consider a coordinate system of ZYZ for Euler angle, that particular ZYZ axis will be represented in this particular form. Z axis, we will be taking Z axis, that is Z comma pi. Then coming to the Y axis, Y comma theta. Then again coming to the Z axis, that is Z comma psi. Right? So, Z by Z axis we will be taking, which are linearly independent. So, this how will you write in terms of matrix form? That particular equation, when we write it in terms of matrix form, as I've told you, it is a 3 by 3 matrix. So, it will be written in this particular rotation. Right? The matrix, that is R11, R12, R13, or row 21, row 23, or row 22, or row 23, or we can tell it as row 31, row 32, or row 33. So here, when we consider theta is equal to 0, if theta is equal to 0, when we are considering theta is equal to 0, the two z-axis will be collinear. Right? The two z-axis will be collinear to each other, as a result of which we will not have any condition of linearly independent term. Right? When theta is equal to 0, in that particular condition, the z-axis will not be equal to linearly independent. Right? The z-axis will not be equal to linearly independent. So, as we have seen in the previous determination of the Euler's angle, R is equal to rotation of z comma pi into rotation of y comma theta into rotation of z comma psi. So, that when we write it in terms of matrix will be written in this particular form, that is R is equal to cos pi into cos theta into cos psi minus sin pi into sine theta as per this angles, as per this particular angles of the rotation, right? As per this coordinate angles, rotation of the angles, we will be writing this particular matrix. Now coming to the R12, we will get minus cos pi cos theta into sine pi minus sine pi cos psi into and R13 will be written as cos pi into sine theta. And next coming to the R21 matrix, we will be getting sine pi into sine theta into sine pi plus cos pi into cos psi. That will be R21, and R22 is written as minus sine pi cos theta into sine psi plus cos pi into cos psi sine pi into sine theta. This will be the overall 3 by 3 matrix. Now in this, how do we calculate the angles? How will we get theta value? How will we get pi value? And how will we get psi value? Right? In order to know these particular values, since here is the only term which we can determine, so first we will be finding what? Cos theta, that is R33 we will be finding out. Right? That is rho 33 we will be finding out. So from this we will be finding theta. Right? From this we will be finding out theta. Now after finding out theta, we can find pi. By using sine theta into sine pi, we can find psi value. From that we can automatically generate the pi value. So in this particular form, we will be calculating all these particular three angles, that is theta, pi and psi. Now if for example theta is not equal to 0, right? Now after we calculate all this, if for example theta is not equal to 0 or if R33 is less than 1, then theta will be written in this form. Right? If R33 is, that is if theta value is less than 1, then theta will be written in this particular equation, that is sigma r cos of theta, or we will write sigma is equal to plus or minus 1. Right? If sigma is equal to plus or minus 1, we will be writing theta in this particular equation and we will be finding out. In the same way, for psi value, we will be taking a tan 2 of R32, that is this value, divided by sine theta, or comma minus R31, that is this particular value, by sine theta. And the pi value will be given as alpha tan 2 of R23 by sine theta, or R of 13, that is rho 13 by sine theta. And in this particular form, we will be finding out the theta, pi and psi values. So these particular angles are called as Euler's angle. Right? So these particular angles are called as the Euler's angle, which are independent of itself and which rotate about its own axis. Right? Any particular angle which are independent of itself and which rotate about its own angle is known as the Euler's angle. Clear? And it will be a 3 by 3 matrix from which we will be finding out the angles theta, pi and psi. Depending upon the value, we will be writing the equations. Clear? Hope you have understood about the Euler's angle. Right? Next, moving on to the homogeneous transformation. What do we mean by homogeneous transformation? What are the applications of this homogeneous transformation? Yes. Before we see that, let us first study about the advantages and disadvantages of the Euler's angle. What are the advantages and what are the disadvantages of this particular Euler's angle we see? And generally, the Euler's angle are provided for a simple and which is used to represent the orientation, as we have told you. That is, in order to find out the simple representation of the orientation, we will be using this particular Euler's angle, which represents a rotation about the specific axis. That is, whether it is x-axis, y-axis, or z-axis. That is the representation of a simple rotation of the orientation about its specific axis. We use the Euler's angle. That is one of the advantage of the Euler's angle. The next one is that it is easy to visualize, as they represent rotation in a fixed reference frame. Right? Euler's angle can be easily found as it is rotated about its own axis. That is, x, y, and z are rotated about its own axis. The visualization and the representation of this particular rotation about its axis will be easy. Right, that is that is the second advantage of the Euler's angle. Whereas coming to the third one, the Euler's angle have been widely used for many years. Since many years, we are using this particular type of the system, and it is and this particular type of the system is still being used in large bodies of existence work. That is, this particular Euler's angle make very compatible with a large body of the existing work. When we are using any when the production is being done in the large manufacturing industry, and when we are using this particular Euler's angle formulation, it becomes easy for us to find out the orientation or position of the robot matrix. Right? So that is one of the disadvantage. Coming to advantage, coming to the disadvantages, the Euler's angle has a drawback of its singularities. Right? It has a drawbacks of its singularities, where two or more rotations can produce the same orientation. Right? When we have two or more rotations being done about its axis, it gives the same orientation. That is one of the drawback of the Euler's angle, where this can lead to the ambiguity in the representation of the orientation and to problems with numerical stability. That is, we will be not getting a exact formulation, exact value when this particular Euler's angle is being used for two or more rotation procedures. And one more disadvantage is that Euler's angle are susceptible for gimbal locks, where two axes become aligned, where two axes become aligned, resulting in a loss of degree of freedom and limiting the possible orientation. When we are limiting it to some particular orientation, if we cannot find out the exact values, so that is one of the disadvantage of the Euler's angle. Clear? So these are the advantages and disadvantages of the Euler's angle. Coming on to the homogeneous transformation matrix. Homogeneous transformation matrix means what? Generally, this particular type of the matrix application is application of homogeneous transformation matrices. Generally, it is used in CAD systems, in graphics, engineering graphics. Right, in these particular areas, we will be using this particular homogeneous matrices. That is, it is a simple transformation matrix which is used to determine the geometry in engines of CAD system. Right? It is a generalized, it is a very, the homogeneous transformation matrix is one of the most important type of the matrix in the geometry engines of the CAD system and in the kinematic models in the in robot controller. In the kinematic models in the robot controller also, this particular homogeneous transformation matrix will be used. So it is very useful for examining the rigid body position or orientation of the sequence of robot links and joint flips. Again, here homogeneous transformation matrix is also used to identify the position and the orientation, but in various aspects, generally used in CAD or graphic modelings, etc. So this particular type of the homogeneous transformation matrix is used for solving the kinematic equations. Right? This homogeneous transformation matrix is generally used for kinematic equations of robot manipulator with many joints. It is described by a single matrix that combines the effect of translation and rotation. Right. This particular rotation transformation operates on homogeneous coordinates and perform rotation about its given axis of reference coordinate system. So when we consider two coordinates, right? When we consider two coordinates A and B, right? Now you can see this figure, right? So here when we are considering the two coordinates A and B, A is drawn on x and y axis, this particular axis, right, which we are terming it as xa, and right, we are terming this is ya, sorry. When the coordinate a is being drawn on x and y axis, this is xa, that is x axis, and this is the y axis, which we are determining it as ya. And next, when we are drawing the x and y axis for the coordinate b, this is the axis x, this will be a dotted line, right? So this is the axis xb along x-axis, and this is the line, perpendicular line yb along y-axis for the coordinate b. Now, for this particular coordinate systems A and B, when we take a perpendicular axis vector, unit vector, when we take a unit vector P along the B axis, this will be BP. When we are considering a unit vector, when we are considering a vector P along the axis B, along the coordinate B, then we get a line, unit vector line as BP. And that, when we are transforming it to the axis A, it is taken as a displacement, right? That a particular line, when we are transforming it along A, that will be written as AD, that is displacement vector. That is displacement vector along the coordinate A. And sorry, this is the displacement vector for the axis B, and when we are extending it, we get to the displacement vector A. Now, when we are drawing this particular perpendicular vector, that is P, that is BP, and when we are transforming it to the coordinate A, we get the vector AP, right? We get the vector AP. Now, let us assume we have a fixed coordinate A and B. Right? This is the fixed coordinate A and B. Right? Now, let us assume that we have the fixed coordinate A and B, which is rotating at an angle theta. Right? It is A and B is rotating at an angle theta. Right, which is a fixed coordinates. Now, how do we write that particular equation? In coordinate B, let us define the vector P, which was written as BP. Right, so when we are taking the vector BP, we, in terms of matrix, we since it is a for the coordinates x and y, we will be getting PBX, PBY is equal to BP. That is, for this particular vector, we will be getting P bx x coordinate by P y coordinate. Right? When we consider the same in terms of A, AP will be equal to PAX and PAY. Right? In terms of coordinate A. Now, how do we write this particular AP? It is nothing but the displacement vector of A plus the rotational matrix B to A into the vector B. Right? How do we write the equation? When we are considering the coordinates A and B, we need to find out this particular vector, your vector of the coordinate A. So that would, in order to find out this, we will be writing as the vector displacement vector of A plus the rotational matrix from B to A into the vector of B, right? So that particular equation is being written in terms, this AP we already know, that is nothing but Pxa by Pya, which is equal to, what is this displacement vector? It is nothing but dxa dya in terms of x and y direction. That is for the coordinate A, for the vector for the displacement vector, for x-axis it is dxa, for y-axis it is dya. Plus, what is the rotational matrix? This is the rotational matrix, right? As we have seen in the rotational matrix geometry, right? When we are having the axis in this particular time, in this particular term, this will be cos theta, right? This will be sin theta, and this will be minus sin theta, right? So when we are considering that, we get the rotational matrix for B to A as cos theta minus sin theta and cos theta. And this vector for the coordinate B we have found as Pxb, Pyb. Now when we are multiplying these particular terms in order to find out Pxa and Pya, when we are multiplying these terms, what we get? Pxa plus cos theta into Pxb, right, is equal to cos theta into Pxb minus sin theta into Pyb, minus sin theta into Pyb. That is Pya form. Now next we when we take that is for Pxa, right? Now next when we take for Pyb, we get it as dya plus this sin theta into Pxb plus this cos theta into Pyb. In this particular form, we write the equation. Now that when we are inserting it in the rotational matrix, we get AP to 1 is equal to the rotational matrix R B to A into the displacement matrix into 1 into 0 into 2 by 1 matrix by PP by 1. That is, the transformation can be written as a single vector matrix multiplication. Now this in terms, what is AP? We are displaying it. When we want a 3 by 3 matrix, we will be taking in terms of a single vector multiplication matrix. So the same here we are inserting. What is this 0 to 2x? It is nothing, 0 value. So we are writing it as 0. So this is the final homogeneous this will be the final homogeneous transformation matrix, right? This is the 3 by 3 matrix when we are considering a single vector matrix multiplication, right? Is it clear? So this is about the homogeneous transformation matrix. So generally the homogeneous transformation matrix is also used to determine the orientation position of the matrix, where it is also written in 3 by 3 matrix, where we are taking two fixed coordinates A and B, and for that we are taking a vector P and the displacement direction, right? That is AD or AD. When it is extended, we to the coordinate A, it will be written as AD, and then we are finding out the homogeneous transformation, which will be a 3 by 3 matrix. Clear? So this is all about your homogeneous transformation, where it is used to determine the orientation position depending upon the various applications. Okay? So this is all about today's class. In the next class, we will be discussing about the forward kinematics and inverse kinematics of the robotics, how they will be used. So signing off for today, Dr. G. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.